So the second type of mechanical system is rotational mechanical system. Again, the difference is that for rotational mechanical system, the force moves about an axis. So let's just remember that for translational, yung first one, it moves along a straight line. So that's the difference. So kapag rotational, instead of force, we refer the force as torque. Okay? And instead of displacement, we refer it now as theta, which is angular displacement. Okay. So in translational mechanical system, we had three basic elements. For rotational, we also have three basic elements, which are almost same as those from translational, but the difference is, first we have the moment of inertia. Of mass. So we can simply call it as mass here, but it is denoted by letter J. Then we also have the dashpot, but this one is for rotational. So dashpot, we also call it as B for friction. And then lastly, we have the, instead of spring, it becomes torsional spring. And we also use letter K for that. Okay. So what are the differences? So ganun din for moment of inertia of mass J, it is a function again of acceleration. For dashpot, it is a function of velocity. For torsional spring, it's a function of angular displacement. So let's draw the three elements. We have the mass, we have the dashpot, so for dashpot, we also have two cases, case 1 and case 2. And then we have the torsional spring, case 1, and then case 2 is when both ends are free. Okay, so this is B, K, K. So for mass, we have here the angular displacement, and instead of force, we use letter T for torque. So the torque due to the mass is in the reverse side, Tj. Okay, so the first one is clockwise and then the other one is counterclockwise. So this is a function of angular acceleration. So your torque due to the angular acceleration is proportional to second order of angular displacement. So T is equal to Tj, still from Newton's law, which is equal to J times d squared theta over dt squared. So this is the formula for mass or inertia. Next, we have the dashpot. For dashpot, we have here the torque and the angular displacement. So the torque due to the friction will be in the counterclockwise direction, TB. So the formula for this is, so TB is proportional to velocity, right? Angular velocity. So T, the external torque, applied torque, is equal to TB is equal to B d theta over dt. So this is for case 1. For case 2, if we apply a force or a torque here, we will have angular displacement 1 and angular displacement 2. And this is the opposing force, TB. So TB proportional to d theta 1 minus theta 2 over dt. So in essence, T applied torque is equal to TB, which is also equal to B d theta 1 minus 2 over dt. So this is for case 2 of dashpot. And then lastly, we have the torsional spring. For torsional spring, lagyan natin ng torque dito, and then yung angular displacement. So the opposing torque will be TK, counterclockwise direction. So TK is proportional to angular displacement. Therefore, T is equal to TK, which is equal to K torque. Angular displacement, or K theta. So this is the formula for spring, case 1. For case 2, if we apply a torque here, there will be torque 1 and the angular displacement 1 and angular displacement 2. So the opposing force TK will be here. So TK will be proportional to, instead of theta here, it will become theta 1 minus theta 2. So T applied torque is equal to TK is equal to K theta 1 minus theta